So I think we completed in work power energy this particular nature of work, and we told that what are the formulas of work. Like work is dependent on these quantities. Work is equal to force into displacement and all, right or not? And also work is related with the particular angle length. Got it? Now today my lectures will go to the depth of this work, and we are going into the depth of work done by variable forces. Got it or not? Even I made you understand work done by pseudo forces and all. We'll come to that, okay? But right now we are going to one particular depth, and that is called as work done by variable forces. Got it or not? Now, but first we need to define the formulas. See, to go into this, the first thing we have to understand that force in the vector form is written as F vector, which is written as Fx I cap plus Fy j cap plus Fz k cap. Even I write my displacement vector in a delta r vector in this vector form, and we write it as delta x I cap plus delta y j cap plus delta z k cap. So work done, this is called as work done in 3 dimensions by a constant force. Work done in 3 dimensions. Okay. If displacement is there in 3 dimensions, then we define work done as basically work done is a scalar quantity. So it will be F dot delta r, which can be also written as Fx delta x plus Fy delta y plus Fz delta z. This is the formula of work in 3 dimensions with which kind of a force? Constant force. But similarly, let's suppose if I take the r vector in variable form, so r vector is written as, means delta r is changed to dr, a small, if I want to write in terms of differentiable, okay, means if force is varying, so then it is written as dx I cap plus dy j cap plus dz k cap. Are you able to get me or not? So then the work done is written as integral f of x dx, because if I take dot product, so we'll write the first form first. It is written as f vector dot dr vector, which is written as f of x dx plus integral f of y dy plus integral f of z dx. This is the form of work done when you consider the 3-dimensional variable form. Are you able to get me or not? Okay, means each term will be integrated. Got it? So we'll pick up one small problems, and then we'll move ahead. Okay, got it or not? So let's suppose a particle there is a point A which has a coordinate 1, 2, 3, and then there is a point B which has a coordinate 2, 3, -1, and a force is applied between them. Okay, means this particle A is taken from A to B by a force 2i cap plus 3j cap. Then question is simple: find the work done by this force. Tell me fast. Find the work done by this force. The Ryan, 5 joule. Abhiraj. So let me check. Mm, So work done is what? F dot x means this is 2 I cap plus 3j cap, and then delta r I have to create. What is delta r basically? So first component is x2 minus x1. So I'm going from A to B. This is my final. Keep that in mind. You have to check that also. This is final. This is what? Initial. So x2 is at final length. Okay, final is what? 2. So I'll write this equation. Okay. So first x2 2 minus 1 I cap plus 3 minus 2 j cap plus uh, minus 1 minus 3 k cap. Now there is no k cap component, so there this dot product will be 0. This is how much? Basically 2, and this is 3. So basically how much it is? 5. Correct. So this was the work done by which kind of a force? Constant force in 3 dimensions. Correct. Let's take another example. If I take a particle from A to B, okay, by a force 2x I cap plus yj cap, okay, and this A coordinate is at minus 1 comma minus 1, and B coordinate is at 2 comma 3. Question is same. Find the work done by this force. Find the work done by this force. Any answer? Array, guys, tell me fast. 15 joules. Let me check. Rehan. This is fully wrong. Let me check. Find the work done by this force. So how do we define work done? Simple formula is there. That sir, first I saw that this force is not constant force. This is basically variable. You have to check it. You have to read it. Okay, this is variable or not. So as it is variable, I have to switch on back to this formula fx dx in plus fy dy or so on. Semi something is no, because this is given variable in the form of vector. Are you able to get me or not? Okay. So okay, let me. I think you need guys a little bit. You try this question first. Then I think it will be good. Okay. Right. What is the work done by the force F is equal to 2x square plus x Newton if the particle travels from x is equal to 1 meter to x is equal to 2 meter. Do this fast. This one will do it fast. Correct? No answer still now. Okay, this work done, this force is variable or constant. You also got Rayan? Correct, very good. 37 by 6 joules. Simple idea. We'll check it, we'll check it. So work done is equal to what? Here there is one, see, this force, you can see that is varying along x-axis or not. Correct? So what I'll use as the force formula, as I can see that the force is varying along x-axis, I'll switch back to only one direction of integration, which is fx dx. Okay, so if I put this value, integral 2x square plus x dx. Now, this work done, I will write it as simple, as there are two terms. So this x is from where to where? 1 to 2 meter. So I'll put the limits. Then I'll do the integration 2x square dx 1 meter to 2 meter plus integral x dx 1 meter to 2 meter. This is 2x cubed by 3 1 to 2 plus x square by 2 from where to where? 1 to 2. If you solve it, you are going to get this answer as how much? 37 by 6 joules. Similarly, in the next question, what I found out that this force, if you look into that, when I'm writing 2xy or 2xi I cap plus yj cap, this force is varying along x-axis and this force is also varying along y-axis. As this force is varying along two dimensions, I'll use the formula of work done as what? Simple. Integral of x dx plus integral f of y dy. Is that clear or not? So if I use this formula of work done is equal to what? 2x dx plus integral y dy. Right or not? Because this is f of x and this is what? F of y. Same something is no? Correct now? I'll put it over here. And then this x goes from where to where? You see that x is going from -1 to 2 and y is going from -1 to 3. So you have to do this -1 to 2 and then -1 to 3. Is that clear or not clear? So this is what? Work done basically is equal to 2x square by 2 -1 to 2 plus y square upon 2 -1 to the power of 3. This is going to give me how much value? Solve it. 2 will cancel. This will be 2a square minus of -1 square plus 3a square upon 2 minus of -1 square upon 2. This one is going to come as 9 joules. It will come as 7 joules, I think. So 4 minus 1, that is 3, plus this is 9 minus 1, which is 8 by 2. 8 by 2 is how much? 4. This is 7 joules. Clear? Hmm? ओके. तो ऐसे ऐसे छोटे छोटे क्वेश्चन पे क्यों हालत खराब हो रही है तुम लोगों की? हालत मत खराब हो ना अपने अपने. अगेन टेक द पॉइंट a same as -1 comma 1 and b as 2 comma 3. We are approaching to the same type of a question, but I'm changing the type of the force. Okay. The force is written as F vector is equal to 2xy I cap plus x square j cap. Try this question. One minute. Try this question fast. Any answer, guys? This is a very classic question. Okay. Okay. Let me put this. How to solve this question? Same thing. This is a variable force, as we can say. Okay, like as we write this, F is equal to 2xy I cap plus x square j cap. I see that variable force, and this is x component and this is y component. If I try to put this in the work done equation, you write it as 2xy I cap is there, so it will come with dx, and this one is j cap, so it will come with x square dy. When you see this question, when you see this, then you in the mind it appears like, sir, here it is y dx and here it is x dy. How to solve this integration? Correct now? You get a confusion like this, saying something, yes or no? So let me just check this one partial form. Try to do the differentiation of d by dx of x square y, where y is also dependent on x. So how do we do this differentiation? If I look into that, then I'll write it as first x square dy by dx, then y will be outside. Chain rule will be applied or not? Why? Because there are two variables. Okay, so y will be outside, and differentiation of x square, which is how much? 2x, correct? Say something, yes or no? Now look over here. Can I just write this as what? D of x square y is equal to what? Basically, it can be simply written as, if I send this dx, denominator dx along right hand side, what I got? X square dy, because this dx and this dx will cancel, and plus twice yx or twice xy dx, twice xy dx. Can you see that? Here, this form, this is one form and this is other form. This form is available over here as f of x, and this form is available over here as x square dy. Means same equation has been broken into a smaller part, where I can write it as this as simply d of what? X square y. You know that if I take integration of differentiation, basically nothing will happen, it will just cancel out. So work done is simply equal to the variable x square y. Now, if you look into that, I'll take the limits. X is taken from -1 to 2, and y is taken from 1 to 3. Simple ideas are there. Something is no. So what I'm going to write? This will be 2 square minus of -1 square. This is x into multiplication of y, which is 3 minus 1. So basically, this is how much? 4 minus 1, 3 into 2, 6 joules is the answer. So sometimes the integration cannot be solved directly. Integrations will go through the process, and that process is this, like taking the small limits and changing into a differentiable form. Are you able to get me or not? Clear, Balaks? Ryan? Okay, so these are some exceptions type question, and means if you see that, it means whenever you see in the question like there is a mixture of variables, try to see, can I write its differentiable form or not? Are you getting me? Like this form? Is that clear? Because sometimes the integration will just change automatically like this. Let's take another question. Let's suppose a particle is taken in xy plane starting from point A, okay, goes to B, then C, then D, and then returns to it. Okay. This is B, this is C, and this is D. Particle goes like this: A, B to C, C to D, and D to A. And this coordinate is A comma, and this is, as you know, x-axis, and this is which? Y-axis. Question is saying, if the force acting on the particle is F vector is given as x square I cap plus y square j cap, Then find the work done by this force. Huh? No, no, it is not 0. It returns back to it. It goes to it goes from A to B, and then it goes from B to Z, then it goes from C to D, and then it goes from D to A. Means it's continuously moving from A to B, B to C, C to D, D to A, with a force which is given as x square I cap plus y square j cap, and then we have to find the work done by this force. This is a closed loop, but since the force is variable, keep that in mind, the net work done is not 0. Okay, when force is variable and you see that there is a closed loop is still, then the net work done is not 0. I'll tell you when the net work done will be 0, when in a closed loop. That happens due to a special kind of forces, not due to variable forces. Right or not? जग गई बालक, इस वीडियो को देखना, ठीक है? तो सुबह सुबह अटेंड कर लेगी ना सोची? हाँ, इसलिए मैं सुबह ही शिफ्ट किया, क्योंकि शाम को भाई बहुत वर्कलोड रहता है, सुबह सुबह ही पार कर दूंगा मैं। ठीक है? हाँ, और अपन का कंटेंट भी अच्छा जाएगा सुबह सुबह। ठीक है, एक क्वेश्चन ट्राई करो, अच्छा क्वेश्चन है, इसके पहले के लेक्चर्स देख लेना। ठीक है, मैंने अपलोड कर दिया है सब कुछ, आज से सब स्ट्रीमलाइन हो जाएगा। तो टाइम लगता है भाई, मेरे को इतना सारा काम रह जाता है। मैंने लिखा है, if the force acting on the particle is F vector is equal to x square I cap plus y square j cap, and the particle goes like A to B, B to C, C to D, and D to A, then find the work done by this force. Ab, when I look at this question, I'll feel like, array, what is this asking? We have not understood, we have never done this kind of problem. But again, if you look into the work done formula, work done formula says that, sir, it is integral f of x dx plus integral f of y dy. Okay, very good, sir. And when you convert it, you get the equation as x square. Hey, 1 minute. One minute. This is little bit problematic. Opposite. Sorry. This is written as x square. Okay, let me erase it first. Okay, let me change the force. This is very simple force, man. Why I give this simple force? It is written as y square I cap plus x square j cap. Acha, if you take x square I cap plus y square j cap, I think the answer will come as 0. Try with this question. Be fast. When I'll write this equation, what I'm going to get it is like y square dx plus x square dy. Correct? Correct or not? Then, yes, this will be the equation or not? Let's, if you want, with f is equal to x square I cap plus y square j cap. I'll come to this. I'll tell about this also. First, try this question. Means let us try with this y square dx and all, and then we'll try with x square and all. Okay. So y square I cap plus x square j cap. If I put what I got as a equation, y square dx plus x square dy. Correct. Now if you look into this, and if the way I'm going from here A to B, B to C, C to D, and D to A, you'll get confused, sir. How to get this? Do we need to do the integration till A to A or something like that? The answer is no. As in the diagram, see here I'm saying you that it is going from A to B, B to C, C to D, D to A. In the exam, they will not be mentioned. They will just mention you this kind of arrows. Keep that in mind. When the work done is shown by the nature of arrows, you have to split the work done into segments. Split the work done into different parts. Start with first one. Work done by AB. Work done in the range AB. So look over here. In this range AB, what is the point? What is my what is my y coordinate value? 0 or not? Say me something, yes or no? Yes. So and value of x is what? Value of x from here to here is 0 to a. So if I try to find the force along, sorry, work done along AB, see that if I try to put this, so what I'll get? I'll get integral as 0 dx plus x square dy. Here from here to here, what is the variation of y? Is y is going anywhere over here? No, no. Balance, is it's only varying along x-axis or not on this particular AB line? So this whole term, since there is no variation, what I'll write? I'll write it as 0. So net work done along AB is how much? 0 by this force. Is that clear or not clear? Okay. Suji, समझ में आ रहा है? Now look over here. If I want, अच्छा ये पॉइंट समझ में आया कि नहीं आया? वर्क डन along AB कि भाई दिस इज द फोर्स इक्वेशन, दिस इज एफ ऑफ एक्स डी एक्स, तो क्या आएगा वाई स्क्वायर डी एक्स प्लस एक्स स्क्वायर डी वाई, क्योंकि ये तो हमारा इक्वेशन है ना. नाउ फ्रॉम दिस वी कैन सी दैट if I look into AB length along AB, the value of y coordinate is how much? 0 or not? 0 or non-zero? बता. It is parallel to x axis or not? और ये origin से start हुआ, तो यहाँ पे y की वैल्यू क्या हो जाएगी? 0. समझ में आई बात? It's parallel to x-axis and it's starting from here, so its y value will be how much? 0 over here. It's starting from origin. Okay, now as y is 0, this first term is how much? 0. And now since it's not traveling along y-axis, so dy will be also how much? 0. So therefore work done along AB will be how much? 0. Are you able to get me or not? Next, work done along BC. If we look into BC, this is parallel to y-axis, correct? So if it is parallel to y-axis and it is present at how much coordinate of x? It is present at, see, look over here, it is present at x is equal to a coordinate. Okay, so here x is equal to a. So it's if I try to write its work done, it's parallel to y-axis. So and as it is parallel to y-axis, you can see that its x coordinate will not vary. Okay, so here dx will be how much? 0. But so therefore, as dx is 0, if I try to write its work done equation, work done along BC, it's parallel to x-axis, present at a particular coordinate of x. So as first term is going to be 0 plus second term will be x value is how much? A square and then dy. So dy varies from where to where? It starts from this point and it goes to here. So it means that it goes from 0 to a once again. So therefore answer is what? A cube. Are you able to get me or not? अब तुम लोग बोलोगे, you guys will say me, sir, what you are doing, sir? Now you see this. This is why basic integrations are very, very important to understand. See, I wrote the work done equation as y square dx plus x square dy. Understand this particular thing, okay? And this is a length and I go till a also. Got it? One part you understand at least, okay? This is A, correct? Got it or not? Now, I want the value of this integration, correct? This is x-axis, this is y-axis. As this is a straight line, parallel to which axis, balance? X-axis. So on this, you can see that if I try to go up and up and up and up, what I'm changing? I'm changing my y value or not? So is I'm changing my x value on this line? No. So it's dx component. Dx means what? A small changes in x. So a small changes in x will be how much? 0. Are you able to get me or not? Tell me. Okay, 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 okay. So this is what? A small changes in what? X. So dx will be how much? 0. Is that clear or not? Now, if I look into the term x square dy, now see here it is fixed at x or not. So x is equal to how much? Constant a. And then here along one variable, what is changing? Dy is changing. So I'll have to just do the integration from x square dy. Is that clear or not clear? So जी समझ में आया अभी बात? ठीक है? तो अपने को देखना है we have to understand what is given as constant and what is given as not constant over there. So this is why it is a cube. Now third term is, if I look into work done along CD, which is, now look over here, if it is CD, it is present at y is equal to how much? A. As it is present along y is equal to A, then work done along CD, if I want to write, now look over here, y a square dx. Now here dx is changing. You look over here. Here x variable is changing along this direction. So dx will exist. Are you able to get me or not? But y component is not 0. And then second component will be 0 because it is not varying along y axis. Is that clear or not? And then dx goes from where to where? 0, a to 0. Is that clear or not? So basically this will be how much? Minus a cube. Are you able to get me or not? Clear? Now look into the last part. Work done along dA. Now if I look into dA, its value of x is 0. So if I write its work done equation, what I'm going to write? Simple idea is that I'm going to write it as, see, work done along dA. Y value is here as along dA, x value will not change. So this one is 0 and x is already 0. So this is total how much? 0. So this is the meaning of this particular integration. Are you able to get me or not? Clear or not clear? So if I want to write its net work done, W net will be given as W along AB plus W along BC plus W along CD plus W along DA, and that is going out to be how much? If you look into that, this is going to be 0 because this is negative, this one is positive. Is that clear? So this is what I'm trying to say. Means work done can be found. Means idea is that work done along closed loop can be 0 or cannot be 0. Here I found out to be 0, but if I change my coordinate like 2a and a, then it will not be 0. Is that clear or not? So your idea is that what you have to do, you have to always write the equations. Is that clear or not? Means you have to always go with the, whenever the force is variable and there is a closed loop, keep that in mind. Don't say that the net work done is 0. Okay, it can be 0, it cannot be 0 also. So for variable force work done in closed loop can be or cannot be 0. Is that clear or not? Say me something, yes or no? Clear? Now moving to the next part. 1 minute. I think this question was little bit mind-provoking question. Okay. Now moving to the next part. See, this whole series was force which was dependent on length, means path basically. Now there is one dependency more, and that is called as when force is dependent on time. Okay, means I write f as f of t, a time dependent force. Go ahead or not? So if force is a time dependent force, I can write it as what? M dv by dt or not? Correct? And as I can write it as m dv by dt, why I wrote it as m dv by dt? Because I can get the velocity equation. But let us see what will happen, what it will impact to the work done. If I replace this f as m dv by dt in any of the particular equations, so what I'll get? M dv by dt into what? Dx basically. This is my work done equation or not? If I put it, then what I get? M dx by dt into velocity v. And if I look over here, dx by dt is again velocity. So what I'm going to get? This is dv. So dx by dt is what? Basically velocity itself into dv. And if I do the integration, I can get this equation. And what I found out, that work done is also equal to what? Half m v final square minus v initial square. Basically this is called as, this thing is also called as change in kinetic energy. Now let me have a clear meaning of this. See, what is this basically? What is this work done is equal to half m v final square minus v initial square? It says that this was work done due to any random force or not, any random force which was dependent on time. Correct? Say me something, yes or no? Abhiraj, okay, na? Suruchi, clear? This is what? Work done by any kind of a force. Now, any kind of a force means what? Let's suppose there is a block, big block, okay, like this way. I placed on an inclined plane, and I attach this block with a spring, and then I applied an F external, and this is some frame, but or not. Even friction is there. And it has an acceleration, it has a weight, how much mg. Okay, so basically you can see that there are many forces. So if I write the work done is a scalar quantity. So work done by this friction plus work done by this mg plus work done by this F external plus work done by some kind of pseudo. There are so many things happening over here that must be equal to something in the nature or not. And this is what they're saying, sir. If I take work done and integral of all the forces present on a body, on a mass m, all the forces, m dv by dt to dx means what? All integration means what? All the forces. Basically, they result into nothing but what? Change in kinetic energy. They result into what? Nothing but what? Change in kinetic energy, and this is called as work energy theorem. That all the natures of the forces, all the bodies, means all the forces which are going to be present on any kind of a body, any body, if I take their all sum, means add all those work done by friction, work done by gravity, work done by external, work done by pseudo, work done by normal, work done by tensor, whatever you take, that is just equal to change in kinetic energy of the body. Are you able to get me or not? And this is called as what? Work energy. Means, why I am saying it as work energy theorem? Because see, how do you categorize a body on which the work has been done? Like, let's suppose I ask you, how do you understand the work has been done? The body means, if on a body, let's suppose there is a horizontal plane, okay, and there is some block placed over here, or it or not, and someone is trying to push it. Someone is pushing. Is that clear or not? So tell me, how do you understand that this person, how, let me write, how do we understand this person has done some work? Basically, for that, you will see that this body is doing some displacement, correct or not correct, Balaks? And as it will do some displacement between this initial point and between this final point, what you are going to see that some velocities are appearing. Here I have a velocity v1, here I have a velocity v2. Means work, if any person does any kind of a work on a body, it's going to change the state of the body. It's even going to change the state of motion of a body. It's going to bring one velocity and then it's going to bring another velocity. Means it's changing the kinetic energy of the body or not. Say me something, yes or no? So this is why I told work done by all the forces. You look over here. Here there are how many forces? Normal, then weight of the body, correct? Then friction, then external force. These are so many forces present, correct? So basically, this is what they are saying, that work energy theorem says that if I add all these forces, if I take the respective physical changes created by all these forces, work done by basically normal plus work done by F external, ultimately my task was to see, I saw that physical change to be just giving us change in velocity. So this is why it is just equal to change in kinetic, nothing else. Is that clear? And this is called as what? Work energy theorem. Clear? Okay. This is the meaning of work energy theorem. That if I add all the forces, I'll get changes into kinetic energy. Now, you might would have heard about change in potential energy, but that is another scenario. That is totally different concept. I'll come to that. Is that clear? Okay. So look over here. Let me try another question. So I'll try another question. Let's suppose on a smooth surface, a block of mass 2 kg is placed, and I apply a force F is equal to 2t square, time dependent force. Okay. So question is find the work done by this force. Find the work done by this force in t is equal to 1 second to t is equal to 2 seconds. Be fast. Okay. Initial velocity is 0. You have to assume initial velocity as 0. 1 minute. Try this question. (64) सुरुचि क्या आंसर आ रहा है? अच्छा, इस तरह के क्वेश्चन कैसे सॉल्व करेंगे? Whenever you get some kind of time dependent force, which kind of a force? Time dependent force. So you have to only do one thing. Simple idea is that keep that in mind. From this time dependent, get the velocity equation. क्या निकालना है इसमें से? Velocity. अब निकलेगा कैसे? So if I told you, F is equal to written as m dv by dt. This is what? 2t square. तो अब लगा दे m dv is equal to 2t square dt, and then do the integration. Mass कितना है? 2 kg. So this 2 kg means this m and this 2 will cancel. So dv is what? Simply v, and this will be what? T cube by how much? 3. But idea is that in this equation, in this particular, don't put the limits. Okay, why? Because here you see that work done is equal to half m v final square minus v. It's not v final minus v initial whole square. Is that clear? So don't put the limits. First you calculate v final. From this, v final is at t is equal to 2, and t is equal to 2 will be how much? Basically 2 cube by 3, which is how much? 8 by 3 meter per second. And v initial is at t is equal to how much? 1, and that is how much? 1 by 3 meter per second. So therefore work done will be simply equal to half m v final square minus v initial square, half into 2 into v final. V final is how much, Bala? 8 by 3 whole square minus 1 by 3 whole square. So this 2 cancel. This is how much? 64 by 3 minus 1. Basically 63 by 9. How much is that? 9 7 जा 63. 7 joules. समझ में आया? सोची क्लियर हुआ है कि नहीं हुआ? ठीक है, एक और क्वेश्चन बनाओ. क्वेश्चन इज सेइंग it says that a force acts on a 20-gram particle in such a way that its position changes according to equation x is equal to 2t minus 3t square plus 2t cube. Then question is, find the work done by this force in first 3 seconds. Be fast. In first 3 seconds. सोचिए क्या आइडिया लगाएंगे, बता जल्दी से, बता 2 मिनट के अंदर सोच. बस वही तो काम है, वेलोसिटी का इक्वेशन निकाल देना है इसमें. जस्ट नाउ आई सेड दैट वर्क डन बाय ऑल फोर्सेस, वेरी गुड, इज इक्वल टू हाफ m v फाइनल स्क्वायर माइनस v इनिशियल स्क्वायर. तो निकालना क्या है इसमें, बस सिंपल आइडिया, 2 हाफ इंटू 20/3. सॉरी, पहले तो वेलोसिटी निकाल ही दो, गलत कर रहा मैं. पहले vt निकालो. vt की इक्वेशन क्या आ जाएगी, इट विल बी dx/dt which will be 2 minus 60 square plus 60, okay, 2 minus 60 only, okay, plus 60 square. Is that clear or not? Okay, so then first 2 seconds, so this means velocity at t is equal to 0 they are asking. So if you look into t is equal to 0, so it is how much, 2 meter per second, and velocity at t is equal to 2 they are asked, 2 first 3 seconds, no? So then I have to find velocity at t is equal to 3. कितना आ रहा है बता सूजी. Solve करो, how much you guys are getting this, means you get this value and huh 40. Let me check. Then you put it in this half into 20 into 10 to the power of minus 3. Whatever you got as v final, कितना आ रहा है 14. 63 is 18 minus 2 6 minus 16 9 6 54. 54 में से घटा दे. हाँ, अबे 72 कैसे होगा भाई, 9 से 54 हुआ ना. हाँ, ये 38 के आसपास आएगा. ठीक है, so this will be how much, 38 square minus 2 square. कितना आ रहा है ये 14.4. This one will be 14.46. Is that clear or not? ठीक है, clear. So this was the work done by all different kinds of variable forces. Is that clear or not? बट अपने पास तीन सबसे खतरनाक क्वेश्चन है जिनके बारे में डिस्कशन करेंगे, बट तब तक एक क्वेश्चन बना लेते हैं। और जो दो क्वेश्चन है जिनके ऊपर पूरी सिर्फ और सिर्फ कल की डिटेल चर्चा उन्हीं दो क्वेश्चन पे होगी, या तीनों तीनों क्वेश्चन को कल ही करेंगे, है ना, डिटेल चर्चा on that three questions. Means go and revise pseudo forces. Tomorrow I will be checking your knowledge of pseudo forces properly. Is that clear or not? Tomorrow your full idea of pseudo forces will be clear. स्प्रिंग फोर्स वाला सैटरडे को मॉर्निंग में करवाएं? हाँ, सट, हाँ बोलो। ठीक है तो, ठीक है तो सैटरडे को, हाँ हाँ, अभी अभी मैं बता रहा हूँ, देख क्वेश्चन। अच्छा अच्छा, एक मिनट रुक, मैं तेरा क्वेश्चन ही देख रहा हूँ। क्वेश्चन बोल रहा है block of mass 2 kg is pushed against a rough vertical wall। तो देख, ये वॉल हुआ और इसके ऊपर एक ब्लॉक रख दिया जिसकी मास कितनी है, 2 kg, is pushed against a rough vertical wall with a force of 40 न्यूटन। ठीक, and coefficient of static friction is being 0.5, mu s is given 0.5, okay, and another horizontal force of 50 newton is applied on the block in the direction parallel to the wall. Then find the acceleration of the block. Hmm, another horizontal force 15 newton is applied on the block in a direction parallel to the wall. No, no, no. Actually, this question is given wrong. Okay, I think this is not horizontal force. आई थिंक ये सारे क्वेश्चंस एच सी वर्मा के हैं क्या? नहीं, मुझे लग रहा है कि ये क्वेश्चन एच सी वर्मा का है, लेकिन ये क्वेश्चन रॉन्ग दिया हुआ है, ठीक है, उस एच सी वर्मा, ये मिस्टेक हुआ था। हाँ, ये बोल रहा है कि ये 15 न्यूटन पैरेलल टू द वॉल अप्लाई किया गया है, ठीक है। इसको क्वेश्चन को रॉन्ग नहीं बोल सकते हैं, ठीक है, थोड़ा ऑप्टिमाइज क्वेश्चन है। ओके, अब ध्यान से देखो, सुनो, लुक ओवर हियर, let me just इसको इसको ड्रॉ, पहले पहले समझो इस क्वेश्चन। सी, आई अप्लाइड 40 न्यूटन, करेक्ट, so there will be some reaction, correct or not, which is some normal n, and its weight will be how much, 2g, correct. So look over here, the normal of this, normal is going to be how much, 40 newtons or not, correct. Now this is 2g. If you look into the limiting value of frictional force, F limiting, how much will be that? F limiting, mu s into n, mu s is how much, 0.5, and then normal is how much, 40. So basically this is how much newton, 5 4 are 20 newtons, correct. And I applied a force of how much newton over here, this 2g is how much, 20. So look over here, what is going to happen if you look into that, F required means required friction to stop it is just 20 newton, which is basically less than my F limiting or not. So what will happen? The body will slide. The body will not slide. Sorry, body will not slide. Correct or not? But here they are asking you the acceleration of the block. Correct? So how to find the acceleration? Means in that only now you have to read this other part. Okay, that another horizontal force of 15 Newton is applied. Okay, in a direction parallel to the wall. So that is not a direction given parallel to the wall. See, I applied in, it means this should be written as in the direction perpendicular to the parallel to the wall, something like that it should be. So let's suppose if I apply a 15 Newton like this way. Okay, then what will happen? My new normal will be how much? 40 minus 15. How much is that? 25. Correct. And then F limiting new. F limiting new will be how much? Mu s into n. Mu s is given 0.5 into 25. So this is how much? 12.5. Now the body will slide or not. So therefore, but here one problem is there. What is the problem? Big problem that as you can see that mu k is not given. So question arises now how the body will slide. Correct? But what? नो 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 नो, ऐसा ऐसे ऐसे नहीं मान सकते हैं. एक मिनट. ये एक मिनट बता रहा हूँ तेरे को. इसका आंसर कितना आएगा? आंसर 2.5 लिखा हुआ है. एक इसका आंसर 2.5 दिया हुआ है बस. मुझे लग रहा है फिर इस क्वेश्चन में कुछ गड़बड़ दिया हुआ है. ठीक है, एक बार देख के ही बता पाऊंगा मैं, क्योंकि इसने बोला है ना कि मतलब 53, मतलब सॉरी, जो क्वेश्चन है वो पहले वाला बोला एच सी वर्मा में भी अब नहीं है. इस तरह ये इस तरह के क्वेश्चन था एच सी वर्मा में. ठीक है, पैरेलल फोर्स लगा रहे थे, बट वो क्वेश्चन अब आई थिंक हटा दिया गया है. एक मिनट देख लेने दे, और देख लेना. नेट फोर्स. अच्छा, एक मिनट इसको देखने दे. इसका हुआ दिस इज 40, दिस इज 15. करेक्ट. इन द हॉरिजॉन्टल पैरेलल टू द वॉल. तो ये हो गया तेरा 20 अलग से. अच्छा, अगर मान ले मैं ऐसे मानूं, ठीक, कि this one will not slide and this 15 Newton is in downward direction. Got it or not? ठीक. अच्छा, सोच जरा, मतलब अपने पास फ्रिक्शन की वैल्यू कितनी है? मींस दिस F limiting is this much. F limiting is कितना? 20 Newton. And And if I look into F required, acha, F limiting is 20 Newton na, and F required is how much? 20 itself. Is that clear or not? So which is basically less than or equal to my F limiting, correct? So the body will not slide. Now if I apply, not in this way, okay, let's suppose if I apply this force of 15 Newton, क्वेश्चन कैसे लिख रहा है, एक मिनट, क्वेश्चन लिख रहा है तेरे को 15 Newton, another horizontal force 15 Newton is applied on the block in the direction parallel to the wall. So let's suppose if I apply in the direction parallel to the wall this 15 Newton, is that clear, like this way in downward direction, void or not? Then the body will accelerate, correct? And the acceleration will be how much? 20 plus 15 minus this is our mu s into n, F limiting, divided by mass, void or not? Mass is how much? 2 kg. So this is how much? 35 35 minus 20, correct? So if it is 35 minus 20, then the answer should come उसमें एक्सेलरेशन नहीं पूछा है ना, लेकिन लेकिन मुझे वही लग रहा है कि ये 15 न्यूटन इन्होंने अलग से एक्स्ट्रा जो ऐड किया हुआ है ना, ये थोड़ा क्वेश्चन में कुछ गलती किया हुआ है, ठीक है। हाँ हाँ, अच्छा क्वेश्चन दिया हुआ है ना इस वर्मा में। हाँ क्वेश्चन नंबर शायद 28 या 29 होगा, देखो तो वही है ना। हाँ तो फिर इस क्वेश्चन में मुझे लग रहा है कुछ गलती है, एक बार मैं देख के पूरे अच्छी तरह से बताऊंगा, ठीक है। अच्छा ठीक है, तो उसको मैं बना के भेज दूंगा तेरे को, ठीक है। अच्छा रुक जा, देखने दे मेरे को क्या लिख रहा है पहले वो। अच्छा ये देख, अ मैन वॉक्स ओवर अ रफ सरफेस एंड द एंगल बिटवीन द फोर्स ऑफ फ्रिक्शन एंड द इंस्टैंटेनियस वेलोसिटी ऑफ द पर्सन पूछ रहा है, ठीक। अच्छा तू ही सोच, कभी भी जो फ्रिक्शन होता है, फ्रिक्शन इज ऑलवेज अपोजिट ऑफ द वेलोसिटी और नॉट, करेक्ट? इफ द वेलोसिटी इज along right hand side, friction will be always along which hand side? Back direction, correct? Friction will be always opposite to the direction of motion, so answer should be always how much? 5 degrees, 180 डिग्री, है ना। आंसर जीरो दे रहा है, देख के बता। A man walks over a rough surface, the angle between the force of friction, ओके 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 ओके, ओ बेटा, सही सही सही, ओके, उन्होंने क्वेश्चन अच्छा खासा उठाया है, देख, समझ, ओके, हाँ ये क्वेश्चन हुआ सही। अच्छा जब मैन, ओके देख, इसी वर्मा में जब न्यूटन्स लॉज ऑफ मोशन स्टार्ट होता है ना, तो उसमें देखना एक फोर्स वाला एक चैप्टर है जिसमें वो हॉर्स वैगन एंड कार्ट का एग्जांपल है, ठीक है। फोर्स का सबसे पहले इंट्रोडक्शन पार्ट, ठीक है, उसमें बोलता है, समझ जरा समझ देख, अगर मैन को आगे बढ़ना है, एक बात बता, मैन की वेलोसिटी क्या है? बी, ठीक। मैन को अगर इस मैन को अगर आगे बढ़ना है, इसको ग्राउंड को क्या करना पड़ेगा? ग्राउंड को पीछे की ओर पुश करना पड़ेगा ना। हाँ तो देख ये क्या लगाया मैन ने, ग्राउंड के ऊपर लगाया क्या? काइनेटिक फ्रिक्शन पीछे की ओर। और you know that कि kinetic friction is a contact force, so there will be equal and opposite reaction of that or not. So this is why kinetic friction on the man will work in which direction? Forward direction. और इसलिए बोल रहा है एंगल बिटवीन अ मैन वॉक्स लिखा है मैन, वहां पे क्वेश्चन पढ़ अच्छे से, क्वेश्चन लिख रहा है हाँ, man walks on the rough surface, the friction, the angle between the force of friction and instantaneous velocity of the person पूछ रहा है, ठीक है, force of friction and instantaneous velocity for the person is how much? 0 डिग्री। समझ आई कि नहीं आई बात? But if I look for, let's suppose if I look the same scenario for the ground, it will be how much? 180 डिग्री। अब समझ में आया? ठीक, नेक्स्ट क्वेश्चन कौन सा था? Which of the following which of the following statement is not true? ये वाला ना, the coefficient of friction between two surfaces will increase if the surfaces are made rough. Correct. When the body slides on surface, the force of friction acts opposite to the direction of applied force. Correct. Rolling force is more than sliding force. No. अभी बात म्यू की वैल्यू क्या है? Is mu can be more than 1? बता, नहीं ना, तो वही तो लिखा हुआ है, the coefficient of friction between wood and wood is less than 1. That is true ना? कोफिशिएंट ऑफ फ्रिक्शन म्यू, नहीं नहीं, अरे कोई भी तू बॉडी ले ले, एक बुक ले ले, एक बुक बिटवीन टू बुक्स, म्यू की वैल्यू क्या है? म्यू की वैल्यू विल ऑलवेज लाई बिटवीन 0 एंड 1. So this means that between two surfaces it can be even less than, it will be always less than 1, it cannot be more than 1. Go it or not? हाँ हाँ, तो इसीलिए हम म्यू की वैल्यू, अच्छा म्यू की वैल्यू इंक्लाइन प्लेन पे इंफिनिटी तक जाती है, तेरे को मालूम है? म्यू की वैल्यू ऐसा नहीं है कि सिर्फ mu on the rough horizontal surface only lies between 0 and 1, but on inclined plane it goes till infinity. Is that clear? ठीक है, तो बस यही तो लिखा हुआ है, समझ में आ गया? ठीक है ठीक है, मैं वो एच सी वर्मा वाला देख के तेरे को बताता हूँ, ठीक है? हाँ, चल फिर इसमें मैंने वीडियो लेक्चर डाल दिया है, एक बार देख ले। और कल मतलब तो मॉर्निंग क्लास, मॉर्निंग में हर रोज अटेंड कर। मैं